Okay, hello, good afternoon, everyone, and thank you very much for joining us to this webinar on teleprotection in power networks. My name is Oscar Pereira, and I work in the commercial department in ZIV. Today's event is part of our 2026 training plan that we call ZIV University, that comprises basically three different approaches. One is the webinars like this one that you are attending today, but a part of this also we organize on-demand training courses and also previously planned courses. So all this information about our training offerings are available in our website, zivautomation.com. So I encourage you to check our offerings there. Today's session will last a total of 30 minutes, as you very well know. So 20 of those minutes will be dedicated to the topic presentation, and then we will keep the remaining 10 minutes for any questions or clarifications that you may need, okay? So at this point, please, I encourage you also to click on the display button that and select the full screen option. This will give you a better viewing experience. And of course, any clarification or any question that you may have, please use the chat feature that you will find also in this tool. Okay. So at the end of the presentation, I will present all your questions and so on. At this point, I am pleased to introduce you my colleague David Hill. David is our application engineer manager for the communications area within the R&D technology department. And in many cases also, David performs as project manager in many teleprotections and high voltage PLC projects. So he's our expert for the topic of today. So I suppose that David is always there. Hello, David, please.
Hello, Oscar. Thank you very much for your presentation.
Thank you.
I'm David Gill. I'm the product manager of communication in the communications area here in CTV. I'm expert in teleprotection and high voltage PLCs. And today we will talk about teleprotection for power networks. Okay. We will talk about two parts inside this presentation. First of all, we'll talk about the different channels that we have nowadays for the teleprotections. And in the second part, we will talk deeply about how is the solution that we have inside CTV about these teleprotections with these communication channels. Okay, go ahead. For more than 30 years, SDH has been the king of the communications inside the substations. Okay, all the main substations in the world has his own SDH node. Okay, where all the communications goes through to the remote substations. Okay. This SDH it's an old equipment. It's a multiplexer that has different possibilities to where all the communications goes to there, and all these services has his own part of this tunnel where to send to the remote site. Okay, but if you are sending or not sending information, that doesn't matter. You have this part of this tunnel only for you. But unfortunately, 10 years ago, it was decided that this technology was not good. It was asynchronous technology, and all the effort in the new developments was focusing asynchronous technology. In that case, the SDH was dying at this moment, and we'll be moving to the switching packet solutions. Okay. The switching packet solution is slightly different because there is not synchronous solution like we have in the past for more than 50 years. All the communications have been working with synchronous channels, and now we are moving to the synchronous channel. It's not so different because everybody nowadays have computers that work with a synchronous packet Ethernet. Okay, but this is different because we are moving in a bitwidth substation. This is different for working there. Why is different? Because okay, you have the information that you need to send is exactly the same, but it's not the same. It's not the same the solution that we are working, because we don't have a special parts in the tunnel for each of us. We have we have a packet to be sending to the remote site, and this packet will first packet that will be arrived will be sent to the other side. As you see here, there is a synchronous one. Each of them has his own part. Here, this packet will be arriving here. That will be sending to the, because arrive first of all. The second one will be the blue, and this one will be wait up to all of them will be sent to the other side. This is totally different than we have in the past, and this change will be create some problems in some specific services. Okay, what is the type of services will be affected with the services that are more restricted with the time. One of them could be the differential line protections, but also the teleprotections. Both of them are very strict with the transmission time and also with the jitter that is created in this type of cases. Here you will see that it could be a lot of jitter in this transmission if this is not controlled. And this is one of the things that we need to go ahead with these transmission channels. Then, what solutions we have? Okay, first of all, we will put some information about the services of teleprotection. I believe that mostly of you knows what is a teleprotection, but I will explain some things about it. Okay, the teleprotection function is the communication between distance protections in order to speed up decisions. Okay, you have here a protection A and protection B, and when you see a fault in the middle of this line, this protection will be sending a trip to the remote site, explaining the distance protection in B that you are seeing a fault. If B is seeing a fault also in this part, everybody will be saying, okay, I need to open these breakers and these breakers. Okay, this is an acceleration services, and this is done. This acceleration is done by the teleprotection part. But also there is another schemes that is if you see that the fault is here and this D is viewing that the fault is here, maybe they can decide to open here. Then there is a blocking scheme where you can see that this C will be sending a trip to D saying, okay, don't open this breaker because the fault is out our line. Okay, there is different schemes that is used inside the teleprotections. When we work with teleprotection systems, there are three parameters that are very important for us. There is the dependability, the security, and the transmission time. Okay, the first one, the dependability, is the ability to detect a command in reception. You say, okay, when you send a command, all the commands will be received in remote site. Yes, but there is no jitter or no noise in the line. When there is noise in the line, maybe this command will be not received, and this probability of missing command is the dependability. Is the PMC, the probability of missing command, that is called dependability. But the other parameter is called security. The security is the ability of the receiver to discern between commands and noise when the channel is degraded. Okay, this is measuring the probability of unwanted command, and nobody wants to receive a false command. It's very important for us to know that you don't lose commands, and this measurement is the probability of unwanted command. And finally, we have the transmission time. This is the maximum acceptable time to detect an order in degraded channels. Okay, I can send a command and maybe I can receive the command in 1 minute, and this is not acceptable for the teleprotection services. This is not a real situation. Okay, this is the reason that we need to have a maximum transmission time, and then when this time arrives, if the command is not received, we decide that this command is not good. Okay, but these three parameters are related with them. If I try to reduce the transmission time, maybe my security would be worse, or the dependability would be worse, If I try to have a very good security, I need a more transmission time, and exactly the same with the dependability. And then when people who work with the teleprotections always are trying to have the best transmission times, but maintaining the security and the main dependability. Okay, if we work in the communication channels, this is the old communication channels. Okay, you have here, you can see that you have two substations, one protection, one teleprotection. Okay, and they are connected through a SDH. This is the world 10 years ago. Everybody in the world, in all the utilities in the world, are working with these schemas. Okay, two substations, teleprotections, and the communication channel between this substation, it was SDH. Okay, here you can have 7.94, maybe E1s, maybe B11s. Okay, it's possible to have a direct fiber here also. Okay, but this is the schema that everybody was working 10 years ago. What happened? As I explained you at the beginning of this presentation, SDH was a very old technology, and the branch of SDH decided to change from technology, synchronous technology, to asynchronous technology. This asynchronous technology is maybe MPLS. Sorry, this MPLS could be a new technology, and it will be connected. We will have a node in each substation. Obviously, when you create these nodes, this is very expensive, but you create this node inside the substation. then maybe the people begin to maintain the SDH at the time that they are constructing these new nodes, these new rings of MPLS. I'm sorry. But the service of teleprotection of differential line protections will be maintained through the SDH. After that, when you are sure that all this MPLS is working properly, in the utilities send the same information through the MPLS and through the SDH. Why this? Because before eliminating the SDH, you should be sure that all this information will be arriving properly at the time, with security and dependability from one side to the other side. Finally, the SDH will be disappeared, and then we'll be maintaining it. If you see here, we are maintaining it old interfaces, C37.94, maybe E1. Okay, all the MPLS in the world has the possibility to be connected to the old or legacy connections. Okay, and finally, this is the ideal situation. You should be finalized working all this connection through Ethernet directly. The teleprotection, in our case, the TPU, has an Ethernet module that will be connected directly to the MPLS. In that case, transmission time will be better, and the security and dependability is in the best conditions. This is the state. This is the state of the in all the utilities in the world will be in each of these stages. Maybe at the beginning, some of them are here. Most of them could be here at this moment, and changing, arriving to this situation. There is some of them that are arriving to here. All of this will be creating different situations, and then we'll be adapting our teleprotection and our differential line protections to these different scenarios that we have here. Okay, if we move to talk about the teleprotection over MPLS, this is, I can say to you, okay, nowadays it's perfectly possible to transmit teleprotection services over MPLS in the perfect conditions. Okay, why this? Okay, because we have been testing this for more than 10 years. Okay, we have tested in labs, and now we have a lot of implementation in real situations. Okay, with MPLS TPs and with MPLS APs, there is a slightly different between the two types of MPLS. MPLS TP, it works with static routes. MPLS IP works with dynamic routes. but both of them are possible to be work with teleprotections. There is no problem to work with it because there is the fabricants of the MPLS are prepared to move this type of services fast and secure. Okay, this is the most important thing. Okay, the teleprotection interface in that case is IP. Okay, we developed in the past interface for IP, the IP channels. In fact, we have renewed the old module to a new module in the last year that accept SFPs also, and the transmission time is nearly 2 milliseconds, 2 and 3 milliseconds at the maximum. Okay, it is very, very, very fast to send commands from one side to the other side. Okay, but also it's possible to have legacy connections to this MPLS. If I put here 67.94 or maybe E1, okay, it's possible to be sent to this MPLS, but obviously the transmission time will be increased because I need to, this 67.94 E1 are synchronous frames, and then I need to convert to an asynchronous one, and in the remote side from synchronous to asynchronous, and then there is 1 millisecond more of transmission time due to these conversions. Okay, for synchronous to asynchronous. Okay, but it's not only with MPLS. There is possible our main solutions at this moment in the communication channels are related to fiber optics, direct fiber optics between the two substations, and we are working also in 4G and 5G solutions. Okay, we maintain the old ones, E1, 67.94, B11, pilot cables, PLCs, but we are seeing that the future is fiber optics, 4G and 5G. Okay, if we focus in these new solutions, we see that in the fiber optics we have a module that is working as C37.94. Okay, this module allows us to work in digital communication at 2 megabits. Okay, and then this is possible to are using an SFP interface and allows the teleprotection to see to diagnostic the SFP, diagnostic directly the fiber optic that you are using. If the fiber optic is more hot, it will be viewing in this DDM, digital diagnostics monitoring, and you can see, okay, there is something wrong in the fiber optic, and then you can try to change these fiber optics in the future. Okay, this is possible using this type of interfaces at this moment. Obviously, the transmission time is very fast. We are talking about 2-3 milliseconds in this, but also it's possible to use the Ethernet module also with this type direct fibers. Okay, our new module is ECPT. It's possible to work with the direct fibers. Okay, has 2 SFP interfaces. Is optimized with the Ethernet frame, and also it's possible to have PRP protocol, and in case that we have redundancy protocols, because maybe we can use one of them with the direct fiber and the other one through the MPLS. This is possible, and also we have the synchronization if we need to synchronize the two substations. Okay, and if we talk about the 4G 5G solutions, when we talk about the 4G 5G solution, we are talking also about Ethernet solution, because there is obviously an asynchronous connections. Okay, then we are working at this moment with Enedis. Enedis is a utility in France. Okay, the main utility in France. Okay, and then they are working with 4G 5G for more than 1 year. Okay, using this solution for some plants or wind plants, okay, to connect the wind plants directly to the substation of the utility. And then in case that they don't have fiber to be connected, they are using this 4G 5G solution. Obviously, there is the main conclusion that we work with it is that this type of channels nowadays has a very high transmission time. Okay, and the most important thing is a very high jitter. Why this? Okay. When you use a channel, a 5G or 4G channel, you are using the same channel that you are using with your mobile. Obviously, the mobile has a lot of interferences with your teleprotection services. And nowadays, it's not possible to maintain the priority for your services, your television service, over the normal 5G channel. Okay, and this is the main reason that this transmission time is quite high. But for special conditions, it could be possible to be used. Okay, maybe it's not possible to be used as a teleprotection services, but it's possible to have as a direct clipping. Okay, if you're using it in a utility and you want to open the breaker in the wind plant, you will be sending this direct clipping to the 5G, and you will be receiving with less than 50 milliseconds. In case of NDs, we are working with less than 70 milliseconds. This is and we see that it's very possible to do it without any problem. We are working now with them to have to close the channel if we have high transmission time or maybe high jitter. And this is a very open thing. But the main thing that we have here, this is a channel for the future. Okay, why this? Because we don't need fiber, we don't need cables to be connected, but we need that the operators will be helping us to do these type of services. Operators are working on it. They are working to have the ultra reliability connections for these antennas where this type of communications will be prioritized for the rest of the communications, and will be leaving a tunnel between the two substations only for this type of services. Obviously, this is not a fast solution because they are working on it. I know that Huawei is working in this area for the future, and maybe in the next 2-3 years, we'll be seeing this communication channel as a main channel in most of these communications. Okay, and finally, we have also inside the TPU the AC6150 compatible. Okay, it's possible to send and to receive commands through the gooses of IEC61850. We have a module that is totally compatible with this IEC61850. We have gooses. It's possible to be programmed with CIDs and ICD files, with redundancy of PRP and ICR, and also with precision type protocol. Okay. As a conclusion, we have we can talk about that the protection is over packet switching network is totally viable. Is possible. There is a lot of utilities that is working with this solution as a main channel without any problem. The MPLS is the perfect task for system for this type of connection with switching packets. Okay, because it's possible to have the appropriate priority assigned to this main service protection services and differential line protections inside the MPLS, and then it's possible to have it. But obviously, you need to be with the MPLS brand to adapt these priorities. The fiber optics remains as a reliable communication channel for these teleprotection systems. Obviously, if you have a direct fiber to substation, our teleprotection is prepared to do it. And also, it's possible to maintain the old connections, the legacy connection, through the E1, 637.94, B11, to these asynchronous interfaces. Okay, but in that cases, this MPLS will be adding some extra delay to this transmission to convert from synchronous to asynchronous and to asynchronous to synchronous in the two sides. Okay, and finally, the 4G, 5G networks are starting to be using as a communication channels, but obviously we need to invest more time with the operators to create these channels, a secure channel for this type of services. Now it's possible in special conditions, like in this case, that they are working with us to develop this system. Okay, and that's all for my side. Okay.
Okay, David, thank you very much. It was a really an interesting presentation and explanations because, we have received several questions, so that is a good sign for the topic. So the first question, David, for you, it comes from our colleague Carlos from the Philippines. And he's asking you if you have any kind of study or reference that from other companies using the C3794. Any do you have any studies or any papers from any utility using this standard?
Yes, I have experience with a lot of maybe a lot. I don't know exactly how many, but there is a lot of people who works with Sister 7.94 as a direct cable. Okay, because we sell with the IOCS in some of them, maybe in the Nordic. Scandinavian countries, believe we have some of them installed there directly with IOCS in direct fiber. We also have this one Sister 7.94 working through the SDH and also through MPLS. Okay, I don't know exactly how many, but we have a lot of them. Okay, this is quite common in many places to work with the Sister 7.94. We have in the past you remember, Carlo, we have in the past IOCT. It was our old interface model for this type of a standard. Now we have the new one, IOCS, and we are working with it in many places.
Okay. In any case, Carlo, if he wants to go in more in depth, you can both get in touch, and you, David, can provide him further details or references.
For sure, I know Carlo. Okay.
Yes, good. Another colleague, in this case from the Emirates, Iqbal is asking, what are the main challenges while migrating from legacy PDH, SDH to IP-based teleprotection networks? Which are the main challenges, you would say, David?
Okay, it's a very good question. Okay, this is the reason that I maintain this one. Okay, if we move here, okay, okay, everybody can be here. When you are here, you are comfortable because you are working without any problem. Okay, you have the E1 connected to the SDH, and you have no problem. The transmission time maybe it's about 4 milliseconds, 4, 5, 6 milliseconds, and you are happy with it. Okay, why do you need to move to the new rings? Okay. Well, first of all, because the standard of the communication channels have changed, and the SDH people have said, okay, I don't want to sell you any more SDH, and then you need to be moved. This is the reason that everybody can decide, okay, I need to change, but I need to be sure that everybody is working properly. The main challenge is, okay, you should be maintained as comfortable as possible with it. We are sure from our as a teleprotection brand that is possible to be sent, because we have a lot of experience with it, and we can help you to do it, okay, without any problem. You can maintain the output of the C37.94 directly to the MPLS. Obviously, you will have 1 millisecond extra, but you will be maintaining 2-3 milliseconds plus 1 millisecond. Okay, you can see here that in this case, okay, you can see that the delay will be 2 milliseconds in that case, but adding 1 millisecond more, maybe you can be talking about 3-4 milliseconds. This is the main challenge. Okay, you should be sure that this is working, and the system is prepared to do it. All the MPLS in the world has the possibility to connect legacy to them, and they are prepared to work with it. And then you directly should be switch on your communication, your teleprotection. In that case, our TPU direct to the MPLS, and okay, maybe you need to adapt to do some tests that the commands will be moving from one side to the other side, and to test that transmission time are comfortable for you with this new situation.
Okay, David, thank you. Let's continue, because we are almost near to to our time, but still we have more questions. For example, one specific question comes from Rexon Manzano. It says, what is the power output in DVMs utilizing SFP? Which is the receive threshold? So, and also finally, if the SFP is a proprietary module in our case. So the power output in DVMs, the receive threshold, and the proprietary issue.
Okay, thank you, Rexon, for the question. Okay, obviously we have a set of SFPs that we have tested with different DVM reception. Okay, we have different possibilities for depending of the type of the fiber and depending of the distance that you are using. You have distance with multi-mode for single mode and different distance for 850 nanometers, 1310 nanometers, 1550 nanometers. Okay, but we can be the proper SFP for your solution. But we have our own solution. Yes, we are not sellers of SFPs. We have tested these SFPs in our equipment. You can put your own SFPs, yes, but I'm not sure that your SFP will be working with my TPU. You can try it by yourself. If it's worked perfectly, that's good for you. But if it's not working, maybe you can send me a mail to me, and then I can try to see what happened with your SFP. But if you don't want to do it, buy our SFPs. That we are not selling SFPs. We are not designing SFPs. We are the only test the SFPs that we know that we are working. Okay.
Okay. Okay, David, another question. In this case, I can answer it directly so that you can take a rest and
thank you
and some water. Well, Osvaldo Espinosa is asking us asking us if we have organized or if we have planned a specific training course in our facilities in Spain for this specific scope. So as I am directly involved with the training courses and the ZIV University, Osvaldo, I will tell you that it is not with a fixed date, so still is not planned, but of course we are open to organize a training course for this kind of scopes. In fact, these initiatives like the seminar of today is just, to touch the customers and the people, and in case we receive a positive feedback and interest, we will be organizing a specific training course of maybe 3 days or something like this in our facilities in Spain, most probably in Barcelona. So I will keep your contact details with me, and in case we finally launch a course on a training course on teleprotection, we will inform you, okay, to you and to any other guy that is interested on the same. And yes, at the end, for everybody, at the end of this session, you will be getting and you will receive an automatic email with the link to review this seminar. And during the next week, directly from ZIV, our marketing department will send you a PDF with the presentation prepared by David, okay? Okay, another question now, David, for you. It comes from Peter Anderson and says like this. The solution with regular line protection systems with transmission over Ethernet is okay. But what about differential protection systems?
Well, it's a very good question. Okay, thank you, Peter, for the question. It's a very good question. Okay, you know that I mainly relationship with the teleprotection, but I know that there is also I used to work also with differential line protections. It's possible to have it. Okay, there is obviously this is more. It's not so easy like with the teleprotections due to the teleprotection is affected by the transmission time, but also by the jitter, but it's more relaxed in these cases. Okay, the problem with the differential line protection is the jitter should be adjusted. We should always have the same jitter. I know that the MPLS people is working deeply with it. Okay, there is well, in that case I've been in touch with some of them. In that case with Belden also, and they work hard reducing the jitter in that cases to be sure that the differential protection could be moved from one side to the other side through the MPLS. In fact, we have the experience here in Spain with Red Eléctrica de España is working with differential protection through the MPLS without any problem. But in that cases, it's very important to have the connection of the boundary clocks inside these systems. Okay, you should be aligned, or that the clocks in all the nodes should be with the same clock. Then it's important to have the same clock in all the network to be sure that when you send information about the differential protection to the both sides are working properly. Okay.
Okay, David, understood. Thank you. Another question, this time from Anton Merkulov. He's asking us if are we planning to develop new module for mobile networks communications?
Well, hi Anton, nice to hear from you. Okay, this is what in our mind. I've been talking with my colleague Marco a lot of times about it. We believe that it could be a good idea for the future. In fact, I believe that it's the future, and we will need to have it in the future. First of all, we need to be sure that everybody is working properly. We are maintaining the work with NEVIS. I believe that for this year to finalize this test, and then we need the help of the operators to be sure that everybody is working, because if they don't put for their side this part, it's important for us to be sure that when we develop this new model, all the channels is prepared for us. Okay, but I believe that in the future it will be the next evolution of the channel is to have a special model for this type of solutions.
Okay, good. Okay, well, yes, to Ahmed Mohamed Goma, yes, as I mentioned before, all of you will receive along the next week this presentation in PDF. Okay, another question, David, for you. Devasudarsan, probably from India, this guy from India, our colleague. Is there a need to implement cybersecurity with TPU over 5G? If yes, will it become more costly?
Well, yeah, it's a good question. Okay, this is one of the things that everybody is worried about at this moment. Okay, there is, as you know, this is teleprotection services are appropriate use and proprietary protocols. Okay, and then we are using with the IP. I believe that they explain you here. Okay, we are using communication securitization. In fact, we are trying to avoid that everybody can see our packets. Can change our packets to create the damage in the networks. Okay, we are working in this part for the future, because if we develop a new model for 4G, 5G, we need to be sure that the cybersecurity will be increased in that case. Obviously, in India, it's not the same than here in Europe. Europe have a very stringent laws at this moment that are inside Europe, the CRA, that will be related to this type of communications. And then to be compliant with it, the cybersecurity is very high for it. And then nowadays we have a quite secure network. Okay, they believe that I'm very happy with it. For the future, if we develop this communication channel for 5G, we need to increase this security. Okay.
Okay, David, another one from Carlos Santos. This has to be with the 5G tests that we perform. Mm-hmm. So he wonders if during those tests, if we were sharing the resources normally with the operator users of the 5G, or if we were using network slicing solutions over 5G SA network?
Okay. Nowadays, the tests are being doing that we are doing in France. We are sharing these channels with the rest of the world. Okay, we are pushing to Enedis to have his sound tunnels to have appropriate connection between the two substations. Okay, this is possible nowadays. Yes, it's possible. But the transmission time in that case is the same, that we need some help from the operators to securize these tunnels, and also to prioritize these tunnels over the rest of the connection that we have in there. I've been in touch with some operators here in Spain, and I know that in case of Fiberdrola is working with Orange, in fact, to doing some tests with this 4G 5G connection for this type of services, the protection, the differential protections, but they are not working as fast as I expect. Okay, I believe that they need to invest a lot of money to do this type of tests, and then sometimes it's not easy. Okay, but we are working on it. Okay, and I believe everybody should be pushing, because I'm totally sure that the future of some of these connections will be using these 4G 5G solutions. Okay.
Okay. Thank you, David. I think that we may have still one or two more pending questions. Well, just Carlos Acharon is saying that, okay, it will be very useful if you can share with him any kind of document to support this, because he needs to present something to the top managers and so on for their existing OTN network. Okay. So more questions. Also from the Philippines, Roy Escobia is asking about our TPU that only has 8 commands. So the question is, can Roy add some commands to use for transit?
Yes, the TPU has the possibility to have transit. Okay, you can have 8 commands in one channel and 8 commands in the secondary channel. Okay, and then you can transit some of them between the 2 channels. Okay, the TPU has the possibility to have 2 channels in the same directions, but you can have also the possibility to have one channel to one side and one channel to the other side, and in that case you can have both of them transited. You can transit from one side to the other side, and to maintain everybody. If they want, they can send me an email, and I will try to explain you deeply, because here it's not possible to have a lot of time, okay, to do it. But it's also possible to have 16 commands in the same direction using 2 different channels. And this is a good question, because we are working on it to have connection with 16 commands. Okay, I expect to have it for the beginning of the 2027 to have in Ethernet and also direct fiber solution with 16 commands. We are preparing the interface model to do it. Okay, I believe that Anton Merkulov knows that we are working on it, because he needs maybe 32, and then we are working to how to deal with it.
Okay, David, thank you. Well, so at this point, I think we should conclude the session of today. Probably.
Let me say one thing, because
yes,
I forgot to tell that as was talking about MPLS, and Carlo was asking me about some information about who worked with it. We have done a lot of tested, but one of the main tested, because we work with it, we have a contact with Belden, with OTN Belden. Okay, it's to work with them. Okay, and then this is one of the reasons that we are sure that all these communications can be done through the MPLS. Okay, in fact, Belden has a solution with 610.94, and also with Ethernet inside his MPLS. Okay, that's all from my side. And thank you very much. Okay.
David, so, well, just to let me ask you very, very short and specific question just to comply with the desire of Z Rongbao. Question very short, says, if use the fiber optic uplink interface, how long the maximum distance can support?
Okay, well.
The last one.
Yeah, the last
I
one.
promise.
Okay. We have tests, but not in line. We have tests in the lab, the SFP to 200 kilometers. Okay, it's not easy to find it. Okay, because there is not so much SFPs that arrive to this distance. We have one SFP tested that works with it. It's not perfect because there is so alarms, but I don't know exactly how many dBs, but there is a lot of dBs to arrive. We have count that is maybe near 200 kilometers. Okay, we are working to find more SFPs, but nowadays we have one of them to do these connections. Okay.
Okay. Okay. Well, guys, to all the audience, thank you very much for your interest on the webinar of today, for your active participation. We are really happy for that and very proud also of having all of you around this round table today. So as I mentioned before, most probably we will be organizing some specific training course in our factories, in our premises in Barcelona, with the participation of our great expert, David. So, okay, stay in line with us through our website because we will be sharing all the information there. So, at this point, thank you very much. As probably you know, we will be organizing webinars like this one every last Thursday of the month, meaning that on next 28th of May, we will have a session like this one, but in this case, it will be related to the line protections. That, as you know, it's a topic very much related with the teleprotections. So another other of our experts, Roberto Cimadevilla, will be presenting this kind of protection and how the discussions between the distance or the differential protection. No, so discussions on how to the best way to protect the line protection and depending on the different criterias. So again, thank you very much, and we look forward to seeing you in the next webinar.
Thank you. Bye-bye.
Bye.